Hi, everyone. Thanks for joining our webinar, What the Helm is Monocular. So just to get things started, I want to introduce our speakers, Jack Francis, the founder of the Helm project, a core contributor to the Monocular project, and lead engineer at Deis. We also have Miguel Martinez, who is a core contributor to the Helm and Monocular projects and senior software engineer at Bitnami. Our agenda today is pretty straightforward. Jack will be covering Helm along with a demo, and Miguel will be introducing Monocular along with his demo. Then we will have a live Q&A, so feel free to please ask any questions that you might have via the chat window, and we will cover them towards the end. With that, I will go ahead and pass the ball over to Jack to get things started.
Thank you, Mavian. All right. So I am going to give a brief overview of Helm. My name is Jack Francis. As Mavian mentioned, I'm a lead engineer at Deis. I'll do a quick pitch. I'll let the website do it for me as to what Deis is. Deis is a company that builds powerful open source tools that make it easy for teams to create and manage applications on Kubernetes. Simple enough. So this is going to be a demo of the Helm product, which we came up with about a year ago. Michelle Nerali, who's also another engineer at Deis and a core member of the Helm team, came up with this deck, and I have used it with permission and culled it down to a more appropriate time for this short demo. So let me start by enumerating some of the problems that we were trying to solve by creating something like Helm. So Deis needed a way to repeatedly install our workflow Heroku 12-factor app paths onto Kubernetes. We wanted an easier way to manage Kubernetes manifests, and we wanted to be able to modify resource definitions for different dev environments so that we could make our sort of manifest of manifests reusable. Enter Helm, which was designed as a way to make defining and installing and managing distributed applications on Kubernetes easier. So some quick stats for Helm. Helm has been extremely successful. I imagine a lot of you guys who are listening are familiar with Helm, but I'll go through a couple of these. So Helm is an official Kubernetes project maintained by SIG apps. There are currently, as of 10 minutes ago, 1,253 GitHub stars, 1,300 active members in the Helm Slack channel on the Kubernetes official Slack. And we have 25 official releases as of now. We're currently at 2.2.3. A big release, 2.0, came on November of 2016. So Helm is what we like to, the initial guiding principle for Helm was we want to build a Kubernetes package manager. So we ended up calling what would be a Kubernetes package, a chart. So there's some nautical references here, so maybe that's some fun trivia for those of you who like to race boats or sail in boats. So a chart is a bundle of information necessary to create an instance of a Kubernetes application. Charts are published to and retrieved from a chart repository. So a repository is a central store for maintaining these chart packages. So Helm is also going to be used as an installer for distributed applications. So it's not only a manifest language to help declare what a distributed application is and its dependencies. We're also going to provide tooling to help put those applications onto your live Kubernetes clusters and get them up and running. And out of the box, we support Go templating. So if you're familiar with that, then it will be a lot easier to write a chart. So a summary of all these little stats and features. Kubernetes Helm makes it easy to install and configure apps. It minimizes chart development overhead by providing some tooling to help you develop charts. It makes collaboration easier. It is meant to ease some of the burdens of operating distributed applications and managing those on Kubernetes clusters. And then this is, shout out to Michelle, this is so you can have more time to drink coffee, to paint your nails, and insert aspirational thing here with that beautiful image. More, please feel free to join, contribute, read more at github.com Kubernetes Helm. So it's, as I mentioned, it's an official Kubernetes project, so it's under github.com/Kubernetes. Quick architectural overview. So let me back up a little bit and describe some of the components of what Helm actually is in practice. So I've been talking about Helm mainly in the context of providing a chart, an interface for declaring charts to manage packages. But Helm in practice is a client and server side. There's client and server side componentry. So you probably can't see my mouse. Actually, maybe you can see my mouse. So on the client side is going to be, the user will interface that via a CLI. And then there is a server-side component running inside the Kubernetes API that we call Tiller, again, another nautical reference, that the client communicates to. And Tiller helps translate a chart into native Kubernetes resources. It deploys those resources into the cluster, and it tracks, it helps to track chart releases over time. So if we start back over here to the far right, we have our Kubernetes cluster, which is running a Tiller service. Tiller service is exposed via gRPC to a Helm client, which is a Helm CLI running on a user's local system. The Helm client then connects to a chart repository over HTTP, which is most likely, for most users, going to be hosted by Kubernetes GCR. So what we call the stable official chart repository managed by the core Helm team under the purview of Kubernetes SIG apps. They publish official chart releases to an HTTP server that's called a chart repository. We also provide a really easy way for you to do local chart repositories or private chart repositories. Miguel from Bitnami is actually going to talk a little bit more about that when he gets to the Monocular part of the demo. So the Helm client will communicate with the chart repository to get charts. It will push those charts to Tiller running in a Kubernetes cluster, which will then render those as actual running operational things. I know I'm speaking pretty quickly here, so I will have some demo, I promise. So I'm going to demo some of these basic concepts with Helm. I've got about probably 10 minutes left. I felt like that was a lot of time, so I printed up all these commands, and I'm going to manually type them in. There's some entertainment value in that, and also it makes sure that I can fulfill the time. So the first thing I'm going to do, I've already downloaded Helm. I've got Helm 2.23. And it's giving me an error there because it's not installed, so I wanted to demo that. So Helm connects to your Kubernetes kubectl context with respect to its Tiller communication. So I'm going to do an initial Helm init, which is going to install Tiller onto my Helm cluster. So now if I do a Helm version, I'll see that it hasn't yet brought up. There it goes. So Tiller is now up, running the same version as the client. It's that second line that starts with server. I'm going to really quickly hop into this just to make sure. Can everybody see everything okay? See, I'm not seeing anything in chat, so I'm going to take that as a yes. Everything looks fine. Right, so let's do a little bit of introspection about what actually just happened when I installed Tiller. So we can see here I'm assuming everybody's familiar with Kubernetes and kubectl. I'm happy to answer questions at the end if you're not. So I'm going to kind of power through some of these Kubernetes specific aspects of things. So I've got a Tiller pod there. If I describe that, and I'm also going to be clearing my screen aggressively to clear up real estate. So we can see that we've got an IP address here in the pod. Here's the image hosted by Kubernetes Helm, the core contributors GCR container registry. If I want to dig a little deeper into how that's exposed as a service, you can see here's a tiller deploy with a service IP and exposing 44134. And that IP should look familiar, so that service is connected to the pod that we previously looked at. So it's a tiny bit of under the hood introspection as to what Tiller is doing server side. So let's get to a little bit more of a common user flow. I'm going to try to demo some of the things that an actual Helm user would be doing. So to dive a little bit more into the concept of a repo, when you first install Helm, it ships with a static connection to what we call the stable repo. This is the official repository for published charts. It also ships with a local repository hook that you can optionally scaffold yourself. So I don't have anything. So when I do a Helm update, which is going to pull in charts from all of my configured repos, you're going to notice an error for this because I don't have a local repository running on port 8879. But it did successfully pull in charts from the stable repository. So now we can list all of the available charts that have been published. So this might look a little interesting, but this is going to eventually segue into Miguel's demonstration. So to list all the charts available, I'm going to do a regular expression search of everything, which dot represents well enough. And you can see here, this is a list of all of the charts that are currently published in the stable repository. So some familiar things, you'll see Drupal, here's Datadog, Jenkins, Linkerd, MySQL, et cetera, et cetera. So let's look at WordPress, which is conveniently also the last one here. So if I want to see what exactly that is, Helm provides actually, let me first demonstrate. If I were a user looking for WordPress, I could do this. I'm going to clear out my screen again. And it would search on that keyword only. So I've found WordPress. If I want to see exactly what that entails, I can do a Helm inspect. Stable WordPress. And I'm going to pipe it to more because I know it's wordy. So at the very top here, Helm Inspect is going to provide you with some basic metadata. And this is going to be descriptive information about what this chart does, a vendor homepage. This is actually not really coming into play now, but it will be coming into play when we demo Monocular. But this is metadata that chart authors can use to describe their charts. And then if we look down further, we start to see some Kubernetes native declarations, like this image pull policy. We had an image URL up there. So these are collections of metadata that help to describe the distributed application in a Kubernetes way that will eventually help Tiller to deploy all of the native Kubernetes resources to run the application. Now, this is a little bit clumsy, and that's kind of the point of demoing this, because I'm going to be passing this off to Miguel for the big finish later. But so one thing you may have noticed is that when I did a Helm search WordPress, it gives me a list of, let me do that one more time, a list of charts that match that keyword. It also said version 0.5.2. Well, if I want to look at all of the versions, then I can do a -- versions argument to that Helm search command, and it's going to give me a list of all published versions for WordPress. Now, a pretty normal thing might be to want to know what exactly is the difference between a couple of versions and why might I want to download 0.5.2 versus 0.5.1. So there isn't much in the way of UX for this currently, so I'm going to demonstrate a way that one could do that, which is to use Helm inspect like I did before. And I can pass it the minus version argument with a version. And let's do 0.5.1 to 0.5.2. So I'm just going to output this to my home directory. Yep. And then let me do the same thing with 2. And then you may have predicted this. I'm going to diff these two things. Version. This is how you get rid of your time commitments in a demo. All right, so if I diff, oh, no def. If I diff these two things, there's only two differences. One is the version metadata, which is obviously different, and the other one is that looks like the container image that runs the basic WordPress application has been upgraded 1 rev. So we've got WordPress 4.7.3 R1, that maps to 0.5.1, and 4.7.3 R2 maps to 0.5.2. The reason why I'm demoing all this rather mundane detail is to suggest that a CLI is not a great environment for doing this kind of introspection. And again, I'm going to be passing off some of the benefits of the entertainment value to Miguel later on, but I'm happy to do that. All right, so let me do an actual useful demo by installing this WordPress. So I've got Tiller running on my cluster, and I'm just going to install this. If you don't pass the version flag, it installs the latest, and that is just fine for me. All right, so you've got a lot of output there. This is enumerating all the native Kubernetes resources that are going to be scaffolded in your cluster. I know that it's going to expose an external service, and it's pending, so I'm going to do one of these commands. I'm going to pass the -w flag, which will fire up an event watcher. And when that pending turns to ready, I will get that information. In the meantime, I'm going to go to another tab, and I can look at some other fun things that are happening. So Laughing Spaniel is the prefix that Helm created to identify this running application. You can see that WordPress had a dependency on MariaDB. So that's a pod. Let's see. There are some persistent volume and persistent volume claims associated with this application. Looks like we are ready. So I am going to go here. Where do I need to go here? Admin. So I haven't used WordPress in several years, in fact. But this should be a real thing. Let's see, am I doing that right? Let's go look at Twitter for KubeCon results while that's, oh, we got it. No Twitter, no need. Okay. I had that ready just in case. All right, so now what we want to do is get the password. So I'm going to, so this is all things that the chart author provided to the user to help them get up and running really quickly. So I'm going to Control-C out of that event watcher. And here is my admin password. So the user is user, and the password is this. I'm not going to save that to my 1Password or to my Safari. And now we are logged on to WordPress. So that was pretty quick. And to prove that this is like a real actual thing and not just a static website, we can update all these plugins. And it's really happening. All right, well so that's all happening. So that is a very, very quick demonstration of the power of, well, for one thing, it's a demonstration of the power of Kubernetes itself to be able to express an application like WordPress with all of its distributed dependencies so cleanly. But it's also the power of Helm to be able to help package these things in a standardized way for anyone to use as a starting point. So there's not enough time in the demo for me to go through the details of WordPress, which would probably be an interesting demo in itself for new Helm users. But hopefully that's enough to whet everyone's appetite. Real quickly, I'm going to do one more functional demo about repositories. So again, we have the stable repository, which ships by default with the Helm client installation. I'm going to do this from my printed reference. I'm old enough to remember paper, so pretty amazing. So I am going to add this incubator repository, which is a Kubernetes Helm managed repository for charts that are on their way to being stabilized, but are still in somewhat of an experimental state. So those are all published to this incubator repository. So now if I look at my repos, I've got 3 now. I can do that canned search to list all repositories, and now I'm going to see the incubator charts as well. And one final thing is, is that Helm can, I've run out of time to do a full lifecycle demonstration, but Helm does have tooling to manage releases over time. And so this WordPress installation that we went through, which is known by the cute prefix of Laughing Spaniel, you can see it's tagged with revision 1. It's currently deployed and running. If I were to manage that Laughing Spaniel over time with future versions of that WordPress chart, perhaps the next version next week references a new WordPress 4.7.4 release, then Helm could manage those releases over time, including rollback. And then, absent actually doing that, I will delete this, which is an interesting, quick thing to demo in terms of lifecycle management. This is the end of lifecycle demonstration. So now if I do a Helm list, I've got nothing. If I do a kubectl get pods, I won't see that anymore. And I think that is the end of my demo. I've got one more slide, which is to get Helm to encourage everybody to go to github.com/kubernetes/helm, download the client, read the documentation, get involved in any way that you'd like. And I'm going to stick around and be happy to answer Helm-specific questions after Miguel has demonstrated Monocular, which is going to be the fun demo, really.
Thanks, Jack. That was great. I'm so glad at least one of the demos worked. So my name is Miguel. I'm a software engineer at Bitnami. And Jack's demo introduced you to installing applications, adding repositories, using the Helm command line tool. So I think we're ready to introduce another tool, another project, which I'm going to explain what it does. I'm going to explain how it works and how it fits into the rest of the ecosystem. So Monocular is an open source project that aims to create a web user interface on top of Helm Chart repositories. If you're a web developer, you might be familiar with websites like npm.js or RubyGems, or you use Docker like Docker Hub. So Monocular in some ways like one of those sites, but for Kubernetes applications packaged as Helm Chart. Some of the goals of the project are, first, facilitate the discovery of Kubernetes applications. We have seen that in Jack's demo that he showed that there is a stable repository, but finding those applications or the ones that are not in the stable repositories is not an easy task. So Monocular aims to expose those charts in a very easy and simple way. Even if you find the different repositories, then there is not an easy way to aggregate them. They can be all over the web. So Monocular offers, again, a simple way to aggregate those repos. Jack showed a very good demo about things that you need to do to see differences between different versions of a chart, and Monocular aims to simplify that. Another thing that you have seen in Jack's demo is the way the type of commands that you need to know to add a repository or to install a chart. So we want Monocular to guide the user, telling them what to do in order to install a specific app. And even we get a step further, which is Monocular should be able, or in some cases is able, to talk directly to Helm and do the deployments or do the life cycle for you. I will demo that in a minute. Another goal is to anticipate the internal repo and search discovery, which means that in some way you should be able to run Monocular internally, being able to share your apps with your colleagues, custom apps or like external apps with your colleagues, and do the life cycle of those apps in cluster. So some facts about Monocular. Monocular, the code is available in GitHub under the Helm organization. And by default, it's configured to use official chart repositories. But that doesn't mean that you cannot add your own. Monocular has support for third-party repositories, and you can think of it like adding a PPA if you are using Ubuntu, for example. But you can also deploy charts within your cluster using a one-click chart deployment, which means that there is no need for a CLI in some specific cases. I'll demo this in a minute again. You have a running instance of Monocular in cubeapps.com, but you can also run it yourself. You can, because it's packaged as a Helm chart, so you just need to follow the instructions that Jack just showed us. But before we go, we do a demo. I'd like to do a quick overview on the architecture so we can understand how it works. We can understand how to fit within the rest of the ecosystem. And also, if you see the different pieces, you might get interested, and if you want to contribute, that would be awesome. So Monocular has two main parts. It has a backend and a frontend. The backend is written in Go. It was bootstrapped by Jack. And the main functions, so one of the main functions is to ingest, get information from those chart repositories every 10 minutes, and get some metadata. So it gets the chart version, it gets the chart name, who are the maintainers. So it gets that metadata and saves it in memory. Then there are another set of metadata that it might be more difficult to extract or require some processing, which is, for example, the case for the README files. The README files are part of the tarbles that represent a release, that represent a version, in which case we need to extract it. And the same thing for the icons. We might want to process it to get a proper aspect ratio. So once we have the backend has imported the metadata and those assets, we expose it via a JSON API, which was generated something, an utility called GoSwagger that allows you to create client and server-side code for the API from a Swagger specification file. So at this point, we have a backend that's ingesting those repositories and exposing it through an API, and that's when the front end comes into play, which is it's a single-page application written in TypeScript and in Angular 2. Which basically takes those assets and shows it in the web user interface. But I would like to stop and zoom out a little bit to explain what kind of integration Monocular has with Helm. So I have already introduced the notion of Monocular ingesting repositories. So this is what I'm trying to show here. We have a Kubernetes cluster that has an instance of Monocular. And this instance of Monocular is ingesting from two repositories. But there is more. Monocular, if you enable a specific feature, will start talking with the server-side component that Helm has and Jack has introduced, which is called pillar. So that way, Monocular should be able to expose the releases, the applications that you have deployed within your cluster, and even deploy them for you. So the demo is going to have two parts. The first one is going to represent the scenario, a public instance of Monocular. In this case, I'm going to show kubeapps.com. But then we're going to deploy our own Monocular. We're going to add our own chart repository and also enable this integration with one-click deployments. So this is kubeapps.com. Kubeapps.com is a running instance of Monocular, which is configured with the default settings, which means that it's importing the stable and incubator official chart repositories, which Jack has already shown. Those repositories can be found, at least the source code can be found in Kubernetes/charts, and the community is working really hard to add new charts every day to curate it and to be sure that there is a good catalog, a quality catalog. So kubeapps every 15 minutes or 10 minutes maybe pulls data and updates the applications that you can see here. So currently we have 69 charts that go from databases to applications like Ghost or WordPress. If you want to do a more advanced filtering, you can go to this chart link. And here you can filter by repository or by when it was created. So let's click in one of the applications. So let's say EasyCD. So this page represents a version of an app, a version of a chart. And as you can see on the left side, we have what is the equivalent to the README, with the README that the backend extracts and renders it in a similar way than GitHub will do. So in this README, you can see what it contains, how to configure it, some other details. On the right side, we have some information. We got the logo, we got some other metadata. What's interesting is here in this box, we get the information on how to use it. This is one of the goals of Monocular, to help to guide users on how to use the Helm CLI itself. So if you remember Jack's demo, he executed this command to add the incubator repository. In this case, you can click here, it will be copied to your clipboard, and then you can paste it in your console. And then you can just click here, copy, and install the specific version. So next, we have the versions. We have a set of different versions which you can switch between them. So this is interesting because most of the time you cannot be in the latest version. So if you want to share with your colleagues, with your team, hey, we're in this version, this is how the README for this version looks like, and these are the changes that are, these are the differences. You can just copy this link, share it with your teammates, and you will not need to do what actually Jack showcased, which was like doing diffs or like trying to unpack the tarbals or going back to the GitHub repository to the source code to see how was the README by that time. So I think this is a very powerful feature. And then we have some other information here about some other metadata, where is the source code, who is the maintainer, and some other. The last feature I want to show is the search engine. So you can search by name, you can search by keyword, you can even search by maintainer. It's very simple but useful. Okay, so we have just shown a running instance of Monocular, running with the default settings. But what if you want to deploy your own in your cluster? In order to do so, first we need a Kubernetes cluster. In my case, I have one running in GKE, but you can have Minikube, you can have one AWS, anywhere. Then you will need to have installed an Nginx ingress controller. You can install an Nginx ingress controller, going to kubeapps, searching for Nginx, going to Nginx ingress, and just copying and pasting this command in your console. So once you have the ingress controller, you just need to download, you need to clone the Monocular repo, and that's what I got here. So here I have the Monocular repo. I have my cluster running, Helm install. So in the Monocular repository, in the docs directory, you should be able to find a deployment guide. In this deployment guide, we explain how to install Monocular in a very simple way. And since I mentioned that Monocular itself is a chart, you just need to do Helm install deployment Monocular. So let's do that. I'm gonna just put a name. So as you can see, this is an identical procedure than what Jack just showed before. So what we're doing here is installing a Monocular chart in my cluster. And some things that we'd like to highlight here is Monocular contains 3 tiers, right? It has an API, which is, I showed in the diagram before, has an API, has an UI, and then there is a pre-renderer, which is a server-side rendering that we can ignore for now. It's not relevant for this. But the other thing that is interesting is we add an ingress resource, and that's the reason why you need to have an ingress controller. So let's see what's going on in the cluster. So we have 2 pods, an API and the UI, which are not ready yet. Let's see what's happening. So if you see the logs, you will see that we have been downloading all the metadata and storing all the cache and processing the icon, processing those assets that I was talking before. So it seems that has already finished. So let's go back and see if they are ready. Okay, so they're all ready. In order to access to this app, we need to find the service IP address for the Nginx ingress controller, which is this external IP address. Okay, so let's visit it. Okay, so here we go. We got a running instance of Monocular, which is identical to QApps.com with the 69 charts, with virtually the same functionality. But what if we want to change this? We want to add our own repository. So in order to do that, you can use the Monocular chart values.yaml file, which is basically the configuration file for your chart, in which, as you can see here, we have a config repositories that lists the 2 official repositories, but you can add your own. So in this case, I'm going to add a Bitnami repository. I'm going to also enable these releases. I'll explain in a minute what that means, and I'm going to change this to my Monocular. In order to apply the changes, what we're going to do is apply an upgrade. So what we can do is Helm upgrade, Monocular webinar, deployment Monocular. And what this is going to do is to apply the new changes to the running release. So I made these changes, but where do I get this? How do I know what I can change? You can know that as if you go to the Monocular repository in the docs directory, you will find a configuration.markdown file in which we explain what are the current options that can be configured. In this case, it's only the repository that you can pull from, but also enabling the Helm releases integration that I'm going to show in a minute, which basically is that connection that is enabling the possibility of Monocular talking to Helm directly on behalf of the user. And then there is another flag like tiller port forward, which is more for development, in which if you're going to contribute, I recommend that you take a look at this file. If you want to see an example file, we have a config.example YAML file that it's up to date and it can be useful too. Okay, so let's see where we are now. So we have the pods, we have the 2 pods, but I want to actually see the logs. And in these logs, there is a difference, which is that now we're also importing from the Bitnami repository. Okay, so it seems that has finished. Let's reload this page, and hopefully it's gonna work. Okay, here we go. So now we have, as you can see, the title has changed. Now it's called My Monocular. Now it has 76 charts instead of 69, I believe that was the number. And the first chart that you get here is Apache. This is sorted alphabetically. So if you click on Apache, in Apache you will see that that Monocular is telling you how to add the Bitnami repository. So it's very easy to use like any third-party repositories. So this is very powerful because you can get like custom-made Monocular in your cluster. But you might have noticed some differences here. The main one is if you go, for example, to WordPress, now you got this button. So this button will deploy WordPress from the user interface. So what's happening now? So what's happening is if we go to this diagram, Monocular, which is this box, it's just talking to Tiller, is either initializing it. If it doesn't exist, if you remember Jack's demo, he did Helm init. In this case, not needed, but because Monocular will initialize that Tiller server-side component for you, and it will tell Tiller, hey, I want to deploy WordPress. So if we go back here, we see a deployment page, which is another random name, and the kind of resources that WordPress contains, which is similar to what Jack showed. On the right side, you have what's the app that you are deploying, what's the chart version, and also the nodes. If you actually we compare it with Jack's demo, this will be the equivalent to do Helm status and the name of the release. So as you can see, this and this is pretty similar. The same thing is that there is a new link here, a new section called deployments, and this is basically the applications that are deployed in your cluster. And as you can see, I have the Nginx ingress controller, but I also have Monocular. I could actually delete Monocular from within Monocular. So in this case, we're going to enter in WordPress. And this is equivalent to do Helm list. You can see we have WordPress, Nginx, and Monocular. So it's equivalent. So now we are here. Let's wait to see what's happening with WordPress. So it seems that WordPress is not ready yet. A second. I might need to go to Twitter too. Okay, here we are. We got running WordPress blog without using the CLI, just using Monocular. So if we go back to here, you can also delete it. So I'm currently deleting the deployment, which is, again, a similar life cycle example that was done with the CLI. So now you go here, it should be gone. Okay, so what we have seen here is first a public instance with the default settings, which is kubeapps.com. But also we have deploying our own Monocular, modifying the title, adding our own repository, and even enabling this integration, this tight integration with Helm. So what's next? Feature-wise, as you might have noticed, there is no any authentication mechanism in place or authorization or not even auditing. So anybody could delete anything. I just deleted WordPress, but somebody else that has access to that cluster, to the Monocular instance, should be able to delete it. But so we want to add something like that. Another field that we want to improve is catalog features. You know, kubeapps.com is great, has those 2 repositories, but it would be great to have some social features, have some comments, have some ranking, and add in some categories. So that's way we can add a bigger amount of charts without polluting it and being able to add categories and making it clear. Regarding the one-click deployment, as you notice, I deployed with the default settings I didn't get any option to modify how I wanted that WordPress to be. So it would be nice if when you click deploy, you get a pop-up which lets you modify some of the values that you have in the values.yaml. But at the end of the day, it's just the API of the chart. The same thing about the upgrades. Upgrades are not supported yet. We also, I would like to improve the releases information, which is giving you that page that shows you the resources, giving you more like interactivity. And then there are other like third-party integrations that I would like to think about, like maybe something like a CV checks that everything that you deploy through Monocular can be checked and you get the vulnerability status, or think about some kind of serverless integration in which you can connect, you can glue different apps together. But these are just some thoughts that would be great if you guys can jump in the GitHub repo and talk about that. So Monocular is part of the Helm community and as part of the Helm project. So I'm going to talk about the Helm community in this case, which is over 100 contributors. It's more than a year and a half old. And you can reach out to us through Slack in the Kubernetes organization Helm channel. We also meet every Thursday at 9:30. And then we do some demos from time to time in CGAPs at 9 a.m. And for sure, we need you. We would love you to contribute. We'd love to hear from you, to get feedback. So please go to that link and let's start talking. This is exciting. Any questions?
All right. So if anybody does have any questions, feel free to chime in with any of the chat clients within the WebEx platform. Otherwise, we do have a couple lined up. Miguel, I think this one is for you. Regarding contributing, how can I help, and do you guys need help in any specific areas?
So we need help everywhere. So we have a lot of like features lined up. This integration with Helm will require a lot of work in the backend side of things, but also in the front end. We need some help in testing in the client. So it's everywhere. We want to scale up the backend to support a bigger amount of charts. We need help in the backend. So short answer is pretty much everywhere. Documentation,
Great.
anything.
Great. Okay, and then Jack, this one's for you. How can I contribute to Helm Chart?
That's a great question. So there is a contribution page on charts, but the short story is to go into GitHub/Kubernetes/charts, learn about how to write charts, get something that's working and has tests written in, and then submit a PR in the Kubernetes/charts repo. And it would be initially shepherded into the incubator directory, which would then get published into the incubator chart repository. Go to Kubernetes/charts, there's a contributing.markdown file there in the root that will help with that.
Awesome. This one's also still for you, Jack. What does the name Helm mean?
That's also a good question. So Helm is, so Kubernetes is Greek for commander in terms of a ship. I think I've got that right, ancient Greek. So from the very beginning, Kubernetes had a nautical, maritime flavor to it and was meant to evoke exploration on the oceans in terms of exploration in the distributed application world. So when we were creating tooling on top of Kubernetes, we were very keen to follow along that maritime vibe. Also, Deis' CEO, Bo, is a basically professional sailor. He's a part-time technologist, professional sailor, I would say. I think he would agree with me on that. And so we wanted to do him some honor by following along with the nautical theme. So Helm is the nautical word for steering wheel on a boat, basically. And the tiller, I know this is the question, but I'm going to say it anyway. Tiller is what a helm connects to actually steer the boat. So we're all up in those nautical vibes.
Right, right. And then for Miguel, any plans on making Monocular part of the official Kubernetes incubator program?
That's a very good question. I guess that we don't know. I would like to let Jack jump into this question as well. I guess that it's too early. It's too early to know. We're building the community. We're trying to prove that this is useful for the community. So I guess that we'll see. Jack, do you want to have anything?
Yeah, well, Helm graduated through incubation, so I would say that Deis has some firsthand experience of the benefits of that. It's not something you want to do lightly. You need people inside the official Kubernetes community to champion your project. And so I think right now the appropriate next step would be to expand the Monocular community of contributors so that if we were to go into the incubation process, we would have a lot of people behind us. But it'd definitely be a best case scenario as far as I'm concerned.
Awesome. So Miguel Pinto has asked the audience, he says, how can we manage the state of all of the apps in my cluster? I'm not sure which one of you want to go ahead and answer that one.
So Monocular, right now, as you saw, the lifecycle operations that you can do, or even the information that you get through the UI, it's very limited, right? So I don't think that can be useful for advanced scenarios in which, for example, knowing what are the dependent charts that your application contains, right? Something that could be useful in Monocular is that you see, you have this WordPress, and this is the MariaDB, and this is where it's going. This is the MariaDB, and this links to the dashboard. But reality is that doesn't exist today. I guess that my answer will be there is not an easy or even a possible way to manage the state of all your apps in your cluster through Monocular today.
Well, so Deis is keenly interested in application lifecycle management, and our heritage is founded on a private 12-factor app PaaS that was originally called Deis, and then as we evolved that to sit on top of Kubernetes, we renamed it to Workflow. Mm-hmm. So in the 12-factor app world, I would say something like that has been able to really successfully manage application lifecycle for apps that can be expressed in that way and that run on top of Kubernetes. In terms of, if your question is how do you manage in one place the set of all distributed applications as individual microservices, I would say that Helm currently can provide, it can get you almost all the way there. The prerequisite would be encapsulating all of those applications inside a single Helm chart. So what you would have to do is to figure out how to decompose your application into components that Helm could describe in a single chart, and then you would manage the releases going forward and backwards by evolving the chart. But that's Deis is keenly interested in those kinds of things, so I would definitely encourage you to hop into the community channel in our Deis Slack, which is deis.slack.com.
Okay, and I think we have one last question that we can get to. Someone is asking, is there a public API on Tiller to launch commands?
Well, there's not a public API. You could read through the Tiller code and deconstruct the REST API. So the REST, it's not as simple as a REST API. It's actually a gRPC expressed API. So I'm not quite sure I understand the question, but there is certainly ways to integrate with Tiller to build things on top of Tiller using the API natively and not relying on the Helm CLI.
So I know that there is a project, I think it's called Rudder, which aims to do something like that. And actually, if you're interested in the use case of having like a JSON API on top of that communicates directly with Tailor, the Monocular backend is doing that. I would recommend you to check out the code and check out. We have some documentation about different endpoints that you can use. And right now, by default, Monocular backend talks directly to the Tailor service. That I think this service now available since 2.2. But also, if you check the configuration settings that we have in Monocular, you can enable port forwarding. So you can try this thing locally. So I would recommend that if you want to do is like do some lifecycle, get releases, and all that, check out Monocular.
Great. Well, I want to thank Jack and Miguel for conducting this webinar. And if there are any other questions, feel free to reach out to either of them. Otherwise, feel free to join the community. And for anyone that's interested in the recording, there will be a link sent to all of our registrants within the next few days. Thanks for joining.
Thanks.
Thanks, everyone.